Assalamu alaikum. I hope you all are doing well. Thank you for joining today. My name is Hira Hameed. I have completed my MPhil in microbiology from the Islamic University of Bahawalpur. Currently, I am working as a research associate in Livestock and Dairy Development Department, Punjab, Pakistan. Today, I am here to present my research entitled as Antimicrobial Activity and Characterization of Zinc Oxide and Silver Doped Zinc Oxide Nanoparticles Fabricated Using Leucophyllum fruitescens leaf extract in the third International Brain and Biomedicines Conferences IBBC 2026. First of all, I will start from the introduction of nanoparticle. As we know that zinc oxide nanoparticles have several beneficial properties, including low toxicity, biocompatibility, biogradability, along with high photostability, thermodynamic stability, and high electrochemical coefficient coupling. Further, we know that green synthesis of nanoparticles, which I have used in my research, green synthesis of nanoparticles has gained a significant popularity in recent years of synthesizing doped zinc oxide nanoparticles as it yields nanoparticles having superior morphological, phytochemical, photocatalytical, and electrochemical characteristics. Here is the methodology of my research. I took fresh Leucophyllum fruitescens leaves, air dried, oven dried them at 100 degrees centigrade for 12 hours, and ground them into a fine powder. Then I prepared aqueous leaf extract. I use 10 gram of powder in 250 ml in distilled water at the conditions as at 80 degrees centigrade for 30 minutes. Then filter it with the Wattsman filter paper number 1 and storing the extract at 4 degrees centigrade. Then phytochemical screening was carried out to detect flavonoids, saponins, alkaloids, carbohydrates, and these different tests. Zinc oxide nanoparticles were synthesized leaf extract into 200 ml of 1.1 molar zinc acetate solution under continuous stirring for 2 hours. Formed precipitate was centrifuged at 8000 rpm for 20 minutes, then washed with distilled water and methanol, oven dried at 100 degrees centigrade for 12 hours, and calcined at 900 degrees centigrade to obtain pure zinc oxide nanoparticles. Silver doped zinc oxide nanoparticles were prepared similarly by adding silver nitrate at different percentages like 3%, 5%, and 7% doping levels into the zinc acetate and leaf extract mixture. Synthesized nanoparticles were characterized using UV visuality, FTIR, XRD, SEM, and TEM techniques to make sure about these nanoparticles. Antibacterial activity was evaluated against, I think this is hide from here. Anyhow, against Bacillus cereus, Salmonella typhi, E. coli, and gram-positive Staphylococcus aureus using different zinc doping concentrations. Here are the dramatical representation of the methodology: leaves, then made powder, solution preparation, filtrate preparation, filtration, extract, centrifugation, and then at the end of prepared nanoparticles. Here are some phytochemical analyses of L-fructans extracts. Here are the results of these research. Figure 1 shows the UV visuality spectra. We can see that different peaks of zinc oxide nanoparticles, then silver doped at 3%, then silver doped at 5%, and then 7%. On the right side, figure 2 FTIR spectra, we can see its different peak values in centi per meter. Phytochemical screening of L-fructans leaf extract confirmed the presence of flavonoids, saponins, phenolic compounds, and tannins. Ultraviolet spectra showed a strong absorption peak around 277 nanometer, as I showed before. Here we can see the maximum peak at 270, confirming successful formation of zinc oxide and silver doped zinc oxide nanoparticles. Further, we did FTIR analysis. This verified the involvement of plant biomolecules and functional groups in nanoparticle formation and stabilization. Then we did XDR analysis. It confirmed the crystalline nature and phase purity of synthesized zinc oxide and silver doped zinc oxide nanoparticles. SEM and TEM images revealed mostly spherical and polyhedral high agglomerated nanoparticles. Here are the SEM images and here are the TEM images. We can see the different values at different levels. Silver doped zinc oxide nanoparticles exhibited stronger antibacterial activity as we checked the antibacterial activity against gram positive and gram negative bacteria. It shows that silver doped zinc oxide nanoparticle exhibits stronger antibacterial activity than pure zinc oxide nanoparticle against all tested pathogens. It means single zinc oxide nanoparticles have less antimicrobial activity as compared to silver doped. The highest antimicrobial activity was observed at 7% at the highest percentage silver doping, especially against Bacillus cereus and Staphylococcus aureus. It means silver doped zinc oxide nanoparticles have more sensitivity against the gram positive bacteria as compared to gram negative bacteria. As I have showed this before to represent these images. Here is caption time images for the synthesized zinc oxide nanoparticles with magnification of 0.5 micrometer, then 100 nanometer meter, then 5 at different concentrations, different percentages. Here is antimicrobial activity of zinc oxide and silver doped zinc oxide nanoparticles. The graph shows the sensitivity bars of different bacteria. Here is the inhibition zone against the selected bacterial strains at a concentration of 50 microgram per ml. We prepared 1 ml solution by adding 50 microgram of silver doped zinc oxide nanoparticles. What we concluded, green synthesis zinc oxide nanoparticles and silver doped zinc oxide nanoparticles successfully produced using L-fructisens leaf extract as bioreducing, stabilizing, and capping agent. Characterization, we did XDR, FTIR, and UV, which confirms high crystallinity, no impurities. Then SEM and TEM also shows, SEM shows diverse nanoshapes in nanometer range. These nanoparticles should have. Then antibacterial potential, silver doped zinc oxide nanoparticle exhibit superior activity. Sorry, whereas gram positive and negative strains enable sustainable eco-friendly water purification. As we have noticed that it is more sensitive against gram positive bacteria than gram negative bacteria. Thank you so much. This is all from my side.